Hi everyone, welcome to my channel. It's been a long while since I posted the videos. Here afterwards, I'll post the videos continuously. From the year class 12 CBSE applied mathematics topics we are going to discuss here afterwards. So it's from the chapter 2 Numerical Applications, Alligation and Mixture. Let's take a look into the concepts and the basic ideology behind this topic. Alligation rule. What it says: when two or more quantities of different values are mixed together to produce a mixture of a mean value, the ratios of their amounts are inversely proportional to the differences of their values from the mean value. That is, amount of quantity of the smaller value over amount of quantity of the larger value, that is equal to larger value minus mean value over mean value minus smaller value. Why we are doing this? We want to get the mixture of our desired price. Similarly, if two ingredients, one is cheaper and the other is dearer, are mixed in a ratio, then quantity of the cheaper article over quantity of the dearer article equal to cost price of dearer article minus mean price over mean price minus cost price of cheaper article, or cost price of a unit quantity of cheaper article, that is C. We are assuming that to be C. Cost price of a unit quantity of dearer article to be D. And mean price will be having in the middle. With the help of that, we are able to figure out D minus M and M minus C. Finally, ratio becomes D minus M to M minus C. That is cheaper quantity to dearer quantity we are able to figure out. This rule only we are using very often in the problems. The alligation rule has its application in the following situations. The first point, when we have to find the proportion in which different ingredients of known values are to be mixed to produce a mixture of a given mean value. Second point says, when we have to find the mean value of a mixture when the proportion and value of its ingredients are known. Third point says, when we have to find the mean or average price of a mixture when the proportion and value of its ingredients are known. Third point only we have come across most of the time. We are trying to find the desired price for the mixture. Mean price we are doing most of the time. First and the second points also we are coming across here and there. When we want to find the proportion or sometimes even the mean value of the mixture. But most of the time, price only we are getting very often. We want to get the desired price for the given mixture. Let's have a look at the keywords. The meaning of the keywords also we should know. A mixture is the physical combination of two or more substances. The substances are known as ingredients of the mixtures. Alligation is nothing but it's an old and practical method of solving arithmetic problems related to mixtures of two or more ingredients. Now let's have a look into the example problem. For the example, MCQ question has been picked. It says, a dishonest milkman professes to sell his milk at cost price, but he mixes it with water and thereby gains 25%. The percentage of water in the mixture is, the options are 4%, 6%, 20% and 25%. Here, the only information they have given us is 25%. That too, the profit. Cost price of the milk they didn't give. Similarly, selling price also they didn't provide. So we are going to make some assumptions here. So what we are going to do means, let CP, cost price of 1 liter milk, be 1 rupee. Then selling price of 1 liter of mixture While we are selling, we are mixing water and milk together. So for the mixture, we are assuming that to be 1 rupee gain, which is 25%. As they have provided gain, using gain, we have got one formula that will apply here. Selling price equal to cost price times 1 plus profit over 100. Selling price of the mixture we know, which is 1. Cost price of the mixture we are going to figure out. 1 plus profit is 25. That 25% only has to be written as over 100. Numerator is simply that value. For that percentage only, 100 has been given already in the formula. So now we are going to take LCM. 100 times 1 is 100. 100 plus 25 will give us 125 over 100. Anyway, we need to figure out the cost price of the mixture. So we are going to bring this fraction on the other side. So while we are moving this on the other side, we need to flip the fraction. It becomes 100 over 125. So that gives us our cost price of 1 liter mixture. Here we can simplify it. So while we are simplifying this, we are getting 4 over 5. So that is our cost price. Now we are going to apply our alligation rule. So here, cost price of the unit quantity we have to consider. So cost price of our 1 liter of milk and cost price of 1 liter of water. That is 1 rupee that we have assumed earlier. For water, it's simply 0. And now we have got our cost price of 1 liter of mixture. That is our mean price, which is 4 over 5. So cost price of our mixture is nothing but, what's the formula? D minus M. So that we have to do here 0, this one. If we take away 4 over 5 from 0, or 4 over 5 minus 0 is nothing but same value. 0 means nothing. So 4 over 5 only we are having here. And here that is 1 over 5. Because we need to take away 4 over 5 from 1. 1 minus 4 over 5. If we take LCM, it becomes 5 minus 4 over 5. That gives us 1 over 5. So now we are going to find the ratio. Ratio of milk to water, that is nothing but 4 over 5 to 1 over 5. Denominator gets cancelled. Finally, it's 4 is to 1. Percentage of water in the mixture. Question is about percentage. Yeah, even though we have found the ratio, the value, question is about percentage. So we need to focus on our 1 over 5 only. Ratio of milk to water is optional. That is not necessary. According to the question, we have to figure out our percentage of water in the mixture. That is nothing but 1 out of 5. So 1. Yeah, this contributes 1. So 1 out of 5 percentage we want. So we need to multiply with 100. So 5 goes into 120 times. So 20% is our actual answer. That means option C. I hope you're able to follow the concept. We'll try a few more questions in our next videos. Thank you. Thanks for watching.